little short video here and on a linear algebra question. So this is from module Math 6038 in MTU. It's a question from autumn 2013 paper. I won't write out all the question here, but I'll read it out. Corporation wants to lease a fleet of 12 airplanes, combined carrying capacity of 220 passengers. The three available types of planes carry 10, 15, 20 passengers respectively. So we have 12 airplanes. There are 10 seaters, 15 seaters, and 20 seaters, and we want to carry 220 passengers. Okay. So the question here is identify three variables x, y, and z. So these are three things that we don't know. Now, one of the things about this question, it probably doesn't include. I'll explain in a second. But the thing is, we don't know how many of each type. How many 10 seaters? How many 15 seaters? How many 20 seaters? They're the things we don't know. So let x equal to, now we should say the number of 10 seaters. If you say x equal to 10 seaters, that doesn't really make sense, because you're saying, what is 10 seaters? It's a type of plane. X is going to be a number. So a number is equal to a type of plane. That's not quite right. X equal to the number of 10 seaters. Y is equal to the number of 15 seaters. And Z is equal to the number of 20 seaters. So we're going to have two equations because there's two pieces of information. There's the information about the number of airplanes, it's 12. So the number of 10 seaters plus the number of, is this part B now, plus the number of 20 seaters must equal 12. And then the capacities. Now this is where what we're going to do is, the question is slightly, oh no, we just have to have the capacity of 220. Yeah, I suppose you see, yeah, I'll show you what I mean. Okay, now if you have one 10-seater, that gives you 10 seats. Two 10-seaters gives you 20 seats. Three 10-seaters gives you 10 by 3 seats, 30. And X 10-seaters will give you 10X seats. So no matter what X is, the number of airplanes, if it's 5, for example, it'll be 10 by 5, that'll give you 50 seats. Plus, similarly, 15Y plus 20Z, this is an equation in seats. Now this should possibly be greater than or equal to 20. But I suppose that made the question a little bit dodgy, because what if someone ran with greater than or equal to 20? So we'll just put equal to 220. So we're going to try and have exactly 220. So it says a combined capacity. Okay. So now we want to solve this linear system. So we put it in Gaussian elimination, or excuse me, reduced form. What's it called? The augmented form. Can't remember. It's been a while since I taught this. So 1x, 1y, 1z equal to 12, 10x, 15y, 20z equal to 220. Now straight away, you're not going to have a unique solution here because there's not enough information. In general, you're going to have as many equations as variables at least to be able to find a unique solution. And if you actually think about this graphically, it's two planes. So x plus y plus z equal to 12. If you kind of look at all the points in space that satisfy that, it's a plane. So it's like an infinite sheet. And we've got two infinite sheets and we're looking for the intersection. Now they could be parallel, the infinite sheets, and there'd be no solutions here. Alternatively, if they're anyway not parallel, they're going to intersect along a line. We can just draw a little picture of that. So the first equation might be given as that should be an infinite sheet. And the second one may be like this. And you'll notice that they intersect along a line. So we're expecting infinitely many solutions. Okay, so what we're going to try and go for is these leading ones, these pivots. Now we have a pivot here, and what we need to do is we need to kill that 10 underneath. We need to get that equal to 0. The different row operations you can do, swapping rows, just means swapping equations, doesn't change the solution. Multiplying a row by a constant is multiplying both sides of an equation by a constant, doesn't change the solution. Adding rows together is like adding equations together, and if you have a long think about it, that doesn't change the solution. And you can combine the last two. You can take a row and add a multiple of another row to it. Now what we want to do is we want to kill that 10. So I need to do row 2 sent to itself minus 10. Now that isn't a row operation, that will change the solution, but if you do 10 multiplied by something, a row, you're okay, and obviously it's going to be by row 1. So we do that, we get 1, 1, 1, 12, and now we get 10 minus 10 times 1 is 0, 15 minus 10 times 1 is 5, 20 minus 10 times 1 is 10, and 220 minus 10 times 12, I suppose, is 100. So now we have this pivot, and we want to make another pivot, and how you make zeros is you use the pivot row, but to make pivots you multiply / divide. So we're going to send row 2 to itself divided by 5. So first row is done. 0 divided by 5 is 0, 5 divided by 5 is 1, 10 divided by 5 is 2, 100 divided by 5 is 20. Okay, and now we are in the reduced form because you've got this step business going on and you have your leading pivots. Now the way the theory works, it says that the gap, essentially the number of pivots is the number of equations, essentially. It's also called, I think, the rank. So number of pivots, which is essentially the number of equations, because you could have 3 equations, but if you end up with a row of zeros, so you'll only have, say, 2 pivots, then you didn't really have 3 different equations. One of the equations is kind of related to the other one. And this thing is called the rank. And the difference between the rank, which is 2, and the number of variables, which is 3, is the number of parameters. So I don't know, number of parameters is equal to the number of variables minus the rank. 3 variables here, rank 2, so there's going to be 1 parameter. So that's one of the variables. Because there's infinitely many solutions, you need something that can take on infinitely many values and can in fact take on any value. And the way you can do it is you can always choose the pivotless column, in other words the pivotless the variable corresponding to the pivotless column to be a parameter. So z can be t and t can be any number at all. Okay, so we can solve, so z can be anything. And now let's find y. So the the final row there reads 1y plus 2z is equal to 20. But of course z can be anything. We're calling it t. And so we get y is equal to 20 minus t, 2t. And similarly we have x plus y plus z equal 12. But y is equal to 20 minus 2t. And z is equal to t equal to 12. So if we solve this here, I think we take away 20 away from both sides. That'll give us minus 8. And we have minus 2t plus t, which is minus t. Add that to both sides. You get x equal to minus t plus 8. So we have x, y, z equal to, say, t minus 8, 20 minus 2t, and t. That's good. Now, the final bit is kind of the trickiest bit. You can kind of do a bit of kind of trial and error, case by case understanding, or you can be slightly more systematic, but depending on the problem, like this could be nasty. So the thing is to note that t, this is probably the easiest way, t can be equal to 0, 1, 2, 3. Now you might say, is 0 positive? Well, if someone kind of said it wasn't, it wouldn't be the end of the world. But in my opinion, 0 is positive. Well, that's not really just opinion. There's a bit more to that. What is a positive number? Well, it's bigger than or equal to 0. There's different ways to explain it. One of the answers is that a positive number is something that's equal to the absolute value of something, and 0 is equal to the absolute value of 0. But anyway, so you can keep putting in these values of t and get solutions. So t equals 0 gives a solution x, y, z. Well, you're going to see this doesn't work, because if you put in t equal to 0 into the first thing, you get -8. That's no good. 20, 0. You can't have -8 10-seaters. So we very quickly see that t has to actually in fact start at 8. So t equal to 8, we substitute that in, we get x, y, z. So I'm substituting t equal to 8 into this. I get 8 minus 8 is 0. 20 minus 2 times 8, 20 minus 16 is 4, I guess. And then 8, so that works. And maybe we'll check our answers afterwards. Let's try 9. So it's x, y, z equal to, so 9 minus 8 is 1. 20 minus 2 times 9 is 2, and 9. And then t equal to 10, we get x, y, z, I probably shouldn't have kept writing that, is equal to 2. And then the next one is 0, and the next one is 10. And notice if you make t bigger than 10, for example 11, this thing goes negative. And so you end up with just these 3 solutions. So I think that's all I'll say about that. Yeah, to be slightly more systematic, you could say I need t minus 8 to be bigger than 0. I need 20 minus 2t to be bigger than 0. And I need t to be bigger than 0. And this might kind of give you the solutions. So this one is I need t to be greater than or equal to 8. And this one you can add the 2t to both sides. I need 20 to be bigger than or equal to 2t. And then this one just says t is equal to 0. And then divide both sides here by 2. You get t has to be less than or equal to 10. And t has to be greater than or equal to 8. But you still have to make sure that they give you whole number solutions, because you could have different types of solutions. Like it could be 20 minus t over 3, for example, and might be the middle one, and so you would need t to be a multiple of 3 for 20 minus t over 3 to be a whole number. Now it's probably reasonable just to quickly check. So this is 12 planes, 12 planes, 12 planes, and then what about the capacity? So this is 4 by 15, which is 60 plus 160, yeah. This one is 10 plus 30 is 40 plus 180, yeah, that works. And this one is 20 plus 200, that works. Okay.